to do 2 redesigns probably, and then you should also make an argument why your redesigns are better, in which way they are better. Since we will be spending about 50% of the lecture time on coding concepts, I will also be asking some conceptual questions about D3 and JavaScript. So for example, like I'm not going to be asking what is the function to change the force parameter in the node link diagram, but I will be asking things like, what is the how does the data binding work? Why do I need to merge a selection before I can apply an update, or before I can do styling? Anything like these conceptual D3 and JavaScript things. Like what is the DOM? What is the relationship between HTML and the DOM? These kinds of questions you should expect. And then there will be a find the bug question. So we'll give you a piece of code, and this will, that will not work. We'll tell you what is not working with it, and then you're supposed to find the bug and write the correction for it. And this is going to be something obvious, so more or less obvious. And yeah, you'll find details in the assignment. So does anybody have any questions about that?
Is the exams next Thursday?
No, it's the Thursday before fall break.
Oh, okay.
So if you're out of the country, can you take it online?
Can you say it again? I can hear you.
I'm going to be out of the country on that day. Can I take it online?
Talk to me later. This is like class time, so you should be here, but we'll find some solution. Anybody? Any other questions?
So it will be of 1.5 hours?
Yes. You will have 1.5 hours. You can leave earlier, of course. It's going to be in here. Okay. My observation is that people tend to not do well on the design critique questions, so pay attention to those. Just pay attention to what we do here in class with the design critiques, and then you should be fine. Okay, next week on Tuesday we will have the D3 lecture on maps, which is what we also need for homework 4. Homework 4 is going to be the last 1-week homework, and afterwards we will have 2 more homeworks coming up with 2-week intervals. On Thursday I'll be talking about interaction, and on that topic we'll be again discussing a paper, this interactive dynamics for visual analysis by Jeff Hare and Ben Schneiderman. So please do read that. I'll call on somebody to give a summary of the paper, and then we'll be discussing it in class. And this is it's not a primary research paper. It is more of like a reflection and an analysis of all the different things. So it is really a good paper for us to read when we go into this lecture. I've also put the link on the website in the schedule. You can find it under the mandatory readings. This is what the next homework is going to look like. We will be visualizing the soccer World Cup that's upcoming, soccer World Cups generally, attendance in soccer World Cups, where they were hosted, and which nations participated. So that's the basic idea. You'll be seeing more of that on Friday. Any other administrative questions? I'll be talking more about projects, but we still have a couple of weeks until we get into that. You could also start thinking about interesting data sets and maybe finding a group in preparation for the projects, but I'll be talking more about projects probably next week. Okay, so design guidelines. So there's 2 rules that you need to really remember. The first one is, and I've been hammering that home I think a lot, is use the best visual channel available for the most important aspect of your data. So you very often have a data set, and that can be shown in many different ways and has many different dimensions or fields or aspects to it. And what you need to do if you want to design an effective visualization is you need to think about what is the key question that I want to answer, and what is which data item shows that the best. And based on that, you choose the visual channel, the strongest visual channel, which is, what is the strongest visual channel that we have? Length? Position? Yes. So essentially what this says is use the strongest visual channel available for the most important aspect of the data. And this is also called the effectiveness principle. So think about what do you want to achieve, what is in your data set, what aspect of your data shows or is most important to answering the question, and then use position for that. The second rule here is the expressiveness principle, and that says the visualization should show all of the data and only the data. This is like, both of those, of course you have them to take them with a grain of salt, but here the idea is that you should visualize the data and not have any extraneous elements that are not relevant to what is in the data in your chart. And we'll be talking about exceptions to these rules for the rest of this class. This is a book recommendation, so if you find this kind of stuff that I'm talking about in this lecture interesting, then there's this Storytelling with Data, a book which is by Cole Nussbaumer. And so she's like a visualization consultant. She gives these visualization workshops for non-technical people. This is like a great book with simple design guidelines. I wouldn't call it a visualization book because she doesn't talk about interactivity and so on, but it's more of like a charting book. How do you create good charts and how do you create good reports? So it's not quite exactly what we do here, but this lecture here is kind of related to what she does in this book. And then, who's heard of Edward Tufte? Show of hands. One person. Oh wow. I would consider him like as famous as somebody gets in the visualization and statistics field. But yeah, so he used to be a professor at Princeton. He is now emeritus, and he was kind of like one of these like old fathers of the field of visualization. And he wrote those 4 books and others, but these are the visualization books. The visual display of quantitative information, and so on. And these are really nice illustrations of, or curations of interesting historical examples. He is really a proponent of this old school visualization of having everything very simple, all the charts, no extraneous elements, and so on. He cares about graphical integrity and visualization excellence. He is a bit of a, let's say, a character. For example, he preaches design excellence. I already mentioned that. Well-designed presentations of interesting data are a matter of substance, of statistics, and of design. It's one of the quotes of him. He came up with this technique that's called Sparklines. He also has trademarked them, and you might have seen these Sparklines. These are just little line charts that you can potentially embed even in text. So here is an example from the 2016 election about Trump's chances in various states and how they have changed over time. And you can see that these are very, very compact, very minimalistic, but they convey like a lot of information, right? So we can see that there was like a couple of events that have increased Trump's chances significantly over time here, and we can compare across these many states just by the arrangement here. He gives these visualization workshops, and he hates and deeply hates PowerPoint. And so somebody on Twitter came up with this figure here: every time you make a PowerPoint, Edward Tufte kills a kitten. If you're ever interested in going to one of his workshops, I think they're, or I hear they're interesting, but there's also a lot of rambling going on. So take it with a grain of salt again. But he has a couple of really important ideas. This is like this idea of showing the data variation and not design variation in charts. That you should have clear, detailed and thorough labeling and appropriate scales, which is something we haven't talked much about, but those two things are really, really critical in visualization, right? You don't want to just show charts, you want to make them like relate to some real world scenario, and therefore scales to be able to judge the size of your marks, for example, and labeling are very important to communicate. And then he introduces this lie factor, which essentially discusses the relationship of the graphic effect to the numerical quantities. So, and he says that these should be directly proportional to the numerical quantities. And so, like, if we express it as a formula, it's size of the effect shown in the graphic divided of the size of effect in the data. And if you're not lying, this should be exactly 1. But if this equation comes down to not 1, then you're lying with your chart. So let me give you an example. So magnitude in the data must correspond to the magnitude of the mark. Here we have a chart from Fox News. This was about the time when the Bush tax cuts were to expire in 2013. And Fox News, unbiased news source as it is, has created that chart. And it essentially shows us, well, right now we're paying 35% taxes, and then once this tax cut expires, we're suddenly paying 5 times as much taxes. Is it what they're really showing here? No. So what's wrong here?
They started the scale at 34, not at 0.
Exactly. So if we calculate the life factor for this chart, we have the effect in the data. In data is a factor of 1.14. So there's like a 14% increase. If you think of it like that, the effect in the graphic is roughly a factor of 5. So 5 divided by 1.14 is a life factor of 4.38, which is of course bigger than 1 and therefore not a great idea. And we'll be talking more about scales later and how to make sense of these, or how to properly design these scales. Here is an example of if you use the zero-based scale, that graphic would look a lot less dramatic. Here is another chart. This is an Austrian newspaper, and this is a right-wing tabloid newspaper that kind of is known for political positions against immigrants and so on. And this is a chart that shows us about all the people who get Social Security and where they're from in Vienna. And so what does this chart look like? Like there is the first is actually the first bar, which is hard to see here, is Austria, and then we have other unknown nations, and we have Turkey, Serbia, and so on. So what's the message in this chart? There's a lot of people from foreign countries who take on Social Security benefits, right? That's kind of the message of this chart. And if you just look at it, it essentially tells us, oh wow, all of those people are using our Social Security benefits. There is a little bit of a hint here that something isn't quite right if you look at the labels. So if we did a faithful chart here, this is what the chart would look like, but it actually doesn't fit on the screen. So here, this long bar are all the Austrians who get Social Security. And now we have kind of framed this in the right context, right? Because we can see it's really only a minority of foreigners that get Social Security in Austria. And these are kind of these things that where the Tufte means by the graphical effect must be proportional to the effect in the data. This is also an interesting chart. It's too easy to make fun of Fox News, but well, if you show bar chart, just make sure that it's in some way proportional to your data. Actual enrollment is higher by labels, but lower by bars. So this is not actually a data-driven chart. So there's this debate about scales and how to start scales at 0. And I'm just gonna you will hear if you talk to visualization practitioners and people, you will find that many people say, well, if you have a bar chart, you never should start your scales at 0. If you have a line chart, that's fine. And I would say that is probably not a good rule. I would actually say that it always very much depends on what you're trying to communicate and how you want to be honest. So here is a chart of the median household income in 2010, inflation-adjusted dollars, from 2000 to 2010. And so what you see, the orange chart, or the orange line here is zero-based and has a scale on the left. And the blue line here is non-zero-based, it starts at 47,000. And so what are the benefits and drawbacks of those two approaches?
With the non-zero base, you can actually see a story.
Exactly. So we have, the variation is very little if we have the zero-based scale, right? We see this hint, we see kind of a little bit of a peak, but we don't see the details. And if we have a non-zero-based scale, we can actually emphasize that effect. And that can be, if you do this faithfully and if you make sure that this is clear, then this is not necessarily a bad thing. But of course, you have to be careful in your legends and your presentations. So you essentially have to ask yourself, is this, what I'm doing here, a faithful representation of the data? What else could you do here to visualize this data without coming into that problem at all?
Show the change by year.
Exactly. You can, instead of showing absolute values, if you want to emphasize the change, then just plot the change, right? Then you don't come into this problem. If you say, okay, between 2000 and 2003, people have lost, or the median household income has decreased by $5,000. You can plot that easily, and then you're not in this problematic area of having to emphasize this with changing your zero scale. So this is a nice video by Fox, and I'm just going to show that.
We make a lot of charts at Fox.com. And of course, charts have axes. And pretty much every time we run a chart with a y-axis that starts anywhere other than 0, someone winds up emailing to complain. You see, there's a really famous book called How to Lie with Statistics, and it contains a discussion of how you can create a misleading chart by messing with the y-axis. And it's definitely true, you can do this. Here's a chart from Fox News, for example. It's a total disaster. But the y-axis dogmatists take it way too far. The big problem with the people who lie with statistics is that they're lying to you. It's true that misleading charts are one way to lie, but the English language is also a tool that can be used for lying. And that doesn't mean we should never speak English. Sometimes you need to fiddle with the y-axis to tell a story properly. So for example, right now, the share of American adults who have a job has fallen to a generation-long low. This is a really big deal. But if you chart this data with the y-axis at 0, you can't see the change at all. Narrowing the range to dramatize what we're talking about isn't lying with statistics. It's emphasizing what's relevant. The way Edward Tufte puts it is you need to use a baseline that shows the data, not the 0 point. And after all, 0 is just a number, like any other. Sometimes to make sense of the data, you need to be able to show numbers that go below 0. Halting at 0 in those cases doesn't make any sense. But extending every chart way below 0 would be crazy too. And of course, where 0 even is depends on the units you're using. If you do a chart of a person's temperature in Fahrenheit, you're likely to miss the fever if you're zoomed all the way out to 0. If you redo it as a Celsius chart, it's not quite as bad. But if you switch to Kelvin and extend everything to absolute 0, then the charts become useless. When people are really lying with charts, the main thing they're normally doing wrong is leaving out the context, not leaving out the 0. Go back to that Fox News chart. You'd never know from this chart that the top marginal rate was 39.6% back in the Clinton administration, or that the Reagan administration was 50%, or that back when Eisenhower was president it was 91%. The missing 0 is really the last of that chart's problems. What they left out was the entire history of taxes in the United States. So just remember, y-axes don't lie to people. People do.
So I think that sums it up very well. So here's another example of like bringing in this contextual information. This is for like a chart for the average temperature between 1997 and 2012 global warming. And so if we look at this chart, what would be a conclusion that we could draw?
Temperatures same on both intervals, like 1997 and 2012.
They stay more or less the same. Yeah. So this is kind of like what you can see in this chart, right? If you did a regression on this, you see this tiny increase here. But again, you need to bring in more context. You need to tell people more about the data, because if we fill in more data, we can actually see that there's quite a bit of a variation here, right? And this is exactly the point that this video was making. So you need to frame the data appropriately to tell the story that is really there, and not just like some selection of a data set that you care about. What is wrong with this chart?
Again, the 55 is just way too high compared to 54.
Yes, so we have the temperature, that is a problem, but it's not the main problem here.
The years are not arranged.
Exactly. So here we have a chart where we show time. And whenever you show time, you have to show time in sequence. You can't just sort by arbitrary years, right? So we have 1921, 1999, 1934. It just doesn't make sense. Of course, what they want to show here is the warmest years up to that, but still, you have to be like, whenever you show time, time is not something that you can move around with. People assume that time progress is linear, and that's usually a safe assumption. So if you have time, you also need to show your data in that order. Okay. What's wrong with this chart? This is a little bit harder to spot, but so this is a similar problem, right? This is like a job loss by a random quarter. And if we actually plotted that on a linear time scale, we can see that this is not a linear effect here. So this problem here was a little bit more subtle. When I prepared this lecture, I really had to look at this chart for a while to see what is wrong. And these intervals look roughly the same. But if you plot them, you will actually find that this is the actual data that's underlying this one. So what's the problem with this chart? This is Republican Party presidential primary schedule. We have the states as our labels for these bars. Then the months are color coded, and the day of the month is shown as the height of the bar charts. It's like completely nonsensical, right? So like bar charts, like you will be hearing like me saying a lot, bar charts are great and you should use bar charts. But there are situations when you should not use bar charts, like this one here, for example. Like it simply, there's no information in here that is like easier to read than just a simple list or a table. And these are actual charts that the people or I myself found on the internet or on Twitter. Okay, so what I'm showing here with the gray bar is the median of a distribution of values. Which value is more likely to belong to this distribution, A or B? Who thinks B? Who thinks A? Who thinks it is? Sam? Sure. Majority. Good eye. So it turns out there is something that's called like biases, and in this case it's within the bar bias. So like we can even plot the data faithfully, but still perceive it wrongly if we're not careful in what we're using. And so here we use the bar chart to represent a distribution and the median of a distribution. But that's not a good choice because the bar chart is good for like a discrete value, but it's not good for the median of a distribution. So if you give people this chart instead, they will be much less likely to make this inference that B, like that B is the more likely value in this distribution. And so everybody here got it right, I'm assuming, because you're like paying attention and are primed on all of these deceiving tricks that I'm trying to play on you. But people have done this as a study, and they have compared these 4 different conditions here, like a gray bar that is framed, a white bar that is framed, an unframed bar, and just like these error bars. And then right next to it I'm showing you the results of this. And their hypothesis was that the framing contributes to a within the bar bias, so that people would assume that if you ask them where is a particular point and plot it here, then they would have a bias, like a strong bias for these 2 frame conditions, would have less of a bias but still some bias for this condition, and would have no bias for this condition. And you can see that this is exactly what happened. So here in this chart we can see that border plus shading, the bias, like there's a strong positive bias. If we just have shading, this reduces, but if we have interval only, we can see that there is almost no bias, or there's no bias on average. So this is was a controlled study just to demonstrate this within the bar bias. And that doesn't only apply for bar charts or for showing distributions, but it also applies for if you want to plot something like a trend line. So here, like this is a paper that is by Michael Correll and Jeff Hare that actually discusses the human ability to do like regression by eye. And it turns out that we're really good at doing regression by eye. So we can spot these trends and are usually like just as correct as calculating these trend lines with the least squares algorithm. And we are also good at spotting nonlinear trends. So people are good at fitting those curves mentally. But when you use a visualization like this, people also tend to simply like bias to the points to be in here, or bias the distribution values in here. So this, like we are less We are much better at mentally fitting a line in here, also in here, but here people tend to put the line not somewhere in the middle here, but tended to put the line somewhere like below here. And so like, if you're interested in this, I can recommend that paper. They also found, which I don't have in the slides here, that outliers, humans tend to ignore outliers if they want to fit a line. That can be good or bad depending on what you're looking at. The next 15 minutes I'll be ranting about pie charts. So pie charts, there is a value in pie charts. What does a pie chart do? It shows you like a part of a whole relationship, right? You have a market, and then you ask, what is the share of my company, for example, in that market? And so, like, generally, this is a good idea. You have something like a circle, which is a whole, and then like pieces of the pie that represents a part of it. So that's kind of an intuitive metaphor. But the pie chart has a couple of downsides. So can anybody come and think about any downsides of a pie chart?
Labeling goes for tasks when sections become really small.
Yes, so we can see that here, that we have basically, there's a couple of elements in here that are so small that they're not even labeled. Other problems?
Some categories have the same color. So.
Yes. So we had this like guideline that we shouldn't use more than 8 colors. Here we have the same color reused, which kind of introduces a relationship where there is none. Exactly. So it violates the expressiveness principle, right? Use the most important channel to show the data, which isn't the case here. Angle is like kind of correct, but there is actually a paper that says that it's not angle what we're reading in pie chart, but arc length. But like most people actually like, well, it's common. It was common knowledge that we read angles here, but in fact we do read arc length. So like the length of this line here. If you read a bar chart.
Perception of the magnitude is kind of difficult because it's a small value, you don't go back and compute the value. So compared to a bar chart, this is much easier to read.
Yes. Yes. So let's take a look. What could we do instead? This is a redesign of this bar chart that gets rid of the color problem, and then it also somehow aggregates the other elements here. But that's still not a great visualization, right? You could instead simply show this as a bar chart, and then you can see those trends very easily, and you can very easily label them, and you can see the distribution. What you're losing here is this part of a whole relationship, but I would say, like, in many cases, this is not, strictly speaking, necessary. Like, this is not the most important thing that you want to convey, right? If you want to say, my share, how is my market share compared to my top 3 competitors, or how is my market share compared to everything? If I do it like this, I can still see, like, I have 23%, I have roughly a quarter of market share. So this is not the ultimate solution, of course, because we lose some information, but it is a better solution, some would argue, me included. So here are 3 different bar charts. Try to, like, can you look at this a little bit and try to spot the differences between these segments in A, B, and C. Can anybody see any trends?
5 is reducing over time.
Increasing over time?
Reducing over time. So from A to C,
yeah,
the brown section is reducing.
The red one is increasing, yes. It looks like it. Did you have a comment? Yeah?
The positions are different at each pie chart?
Yes.
Or the sections?
Seems like the only areas changing are the red and the brown. The yellow, green, and blue seem to be the same throughout.
This is black for me. You mean that one? Okay. Yeah. So we can kind of like look at this and try to eyeball it, but then we can plot it as bar charts. And while I don't think these are the nicest colors, especially the yellow one, we can very clearly see trends here, right? We can clearly see the relationships. We can basically monotonously increasing relationship here is almost not visible. We can spot the biggest segment, but it's hard for us to spot a trend here. whereas this here is the inverse relationship. So again, this just shows you how much easier we see these kinds of trends in bar charts than we do in pie charts. Like this here is my favorite pie chart. It shows a portion of sky, sunny side of the pyramid, and shady side of the pyramid. And my second favorite pie chart, the pie I've eaten and the pie I haven't eaten. So what do we do instead? So here is like an example, and you've seen these pie charts, and I can use them as bar charts, I could use them also as stack bar charts and so on. But here is an interesting example where we also want to do a comparison. So this is an illustration from Cole Musburger's book, where she had a data set where kids were going into an education program about sciences. And they had this pre-study questionnaire and this post-study questionnaire. And the questions here were, how do you feel about doing science? And they had like 5 choices between bored, not great, okay, kind of interested, excited. And so in the pre-study questionnaire we can see that like 40% of the people said okay, and then like 11% here were bored and 5% said that we were not great. In this post questionnaire we see that the excited share grew significantly and the okay share shrank significantly. So this is not one of those tricky cases where the pie chart is hard to read because we have too many segments and too many colors and so on. But still, making this comparison is quite effortful for us. So here's a couple of redesigns for that. First, we could show the numbers directly. So we could say, after this program, 86% of kids expressed interest towards science compared to 44% before going into the program. Just numbers, just a sentence. Works fine. The second alternative is to show a bar chart. So here we can see that people who were bored or didn't find it great in the first place, they failed to convince them basically. Even the segment increased a little bit, so from 11 to 12 and from 5 to 6%. But they had a massive impact on those people that were kind of oblivious and they said, okay. And those seem to have shifted into the kind of interested and excited segment. So we can see that from the kind of interested, that increased slightly, the excited segment increased a lot. So that is one alternative. Then we could do this 100% stacked horizontal bar graph. And so here, what does she do with the color here? I couldn't hear you.
They combine the two groups.
Exactly. So they made a decision not to show 5 colors, but they said, okay, we're just gonna like reclassify bored and not great into one group, and then kind of interested and excited in the other group, at least for the purpose of color. And so we can see here that the people who are at least kind of interested significantly changed, and especially the OK segment decreased quite a bit. So I would argue that this is a pretty good representation. Of course, we have these problems that if you want to make a comparison of like those 2 segments here, that is hard because we have to compare length. And so these are unaligned length comparisons, which are harder than position comparisons. The final alternative is this slope graph here. So you could plot it like this, and these slope graphs they're pretty good for temporal data, and you will be seeing them more and more in various newspaper publications. So you can see this massive drop for the OK people and this increase for the excited and kind of interested people. What's the main problem with this chart? So what did this chart here better than this one?
Proportions better.
Proportions, yeah. So we don't really get a good sense of how many people are excited or kind of interested taken together, right? We have these like overall proportions, like we have these individual categories here that are shown, and it's hard to show. In theory, we could like add an aggregate value here, but this is going to be quite off the scale. So this is hard to show in a slope graph like this. Okay, a couple of like visualization design principles according to Tufte and other people, like maximize the data to ink ratio. I think we've talked about how the problem of D3, but here is a chart. We could simplify that to this like a flat chart that simply conveys exactly the same information. We're using a lot less ink to visualize the same data here. We should avoid chart chunk. So here, what could I do to remove extraneous elements in this chart? I can get rid of the grid lines. What else? The boundary. Can I get rid of the background?
The right scale that you have.
Yeah, I only need one scale. I could even go further and could say, well, I don't actually need the other scale here either. So this is kind of like a radical simplification now. And this chart conveys pretty much the same data as actually, I would say it's a lot more beautiful, a lot more easy to assess. We don't have like any reduction in quality, probably even an increase. So if you look at those two charts, like here's Diamond prices, this is like a Nigel Holmes chart. Nigel Holmes was this newspaper graphics designer, or is this newspaper graphics designer, he's still active, who created these very like interesting charts. And so this is a chart of diamond prices from 1978 to 1982. And like the title here is Diamonds Were a Girl's Best Friend, kind of showing that this is a town that they have experienced quite a downward trend. And so I'm showing you here one handcrafted visualization with a lot of extraneous elements where we have a lot of stuff that is not the data primarily, and then a very neutral chart on the right. Which do you prefer?
If it was a magazine, the left-hand side.
What's that?
If it was like just flipping through a magazine, probably the left-hand side one.
Yeah, the left side one. And why? So this chart is engaging, right? It tells a story. And so we have this trade-off between essentially making something engaging and exciting and representing accurately the data, or at least that is what we think, that there is a trade-off. But here's another example, which I just recently saw, and I like a lot. This is about the German problem about the increasing balance, the trade deficit or the trade surplus that Germany has. And I found this interesting because they used the bar chart here and made it look as part of the wings of this eagle. So another example of an interesting chart chunk, use of chart chunk. So here's another one. This is total House and Senate campaign expenditures. So what is wrong with this chart here?
The triangles don't make too much sense for embedding information.
Yeah, the triangles are not great. And then we have like a curved scale, right? We have all of these extraneous elements, so it's not this reductionist approach. Who prefers the clean one? Show of hands. Who prefers the monster? The majority prefer the monster. So yeah, this is an interesting trade-off, right? And people have actually studied that. This is a paper that was kind of like hotly debated a couple of years ago. It's called Useful Chunks, the Effect of Visual Embellishment on Comprehension and Memorability of Charts. And so what they found is, and they did exactly like they used lots of Nigel Holmes charts, and they compared it to very minimalist redesigns. And so what was it that they found? Well, they didn't find any differences for interpretation accuracy. So when people were asked about what is in the data, they actually did exactly as well in interpreting it accurately. They didn't have any difference in recall accuracy after a 5-minute gap. So if people were shown these two charts and then 5 minutes later asked about what was in those charts, there was no difference. But they had significantly better recall for the Holmes, these chart chunk charts, of both the topic and the details after a long-term gap, after 2 to 3 weeks. So what this comes down to is that those charts, they're not necessarily harder to read, and they're not better for understanding, and they're not better for short-term memory, but they are very memorable. we can remember what was in this chart a couple of weeks later, much more likely than if we had a boring chart. And then participants qualitatively also found that the Holmes charts were more attractive. Most of the participants enjoyed them and found that they were easiest and faster to remember. So these are experimental results, and kind of a lot of debate followed that paper. So is chart chunk useful? Well, I would say it depends. First, I guess what I don't have on here, but the most important thing is, of course, you have to do it well. And creating these Holmes-like illustrations is, of course, a lot more effort than just drawing a simple bar chart. But if you do it well, and if you don't make any of the obvious mistakes that we discussed with, like getting scales wrong or getting the data wrong and so on, what is the benefits of using chart chunk? Well, we have persuasion. You can actually make a point, right? This chart with the monster here, that's not an unbiased representation of the data. It has an agenda. It wants to say, well, this is a problem. Compared to this chart, which is just an unbiased representation of the data. We have memorability and engagement as the pros. The cons is, of course, that it's biased, and then they don't look very trustworthy. They can sometimes, if you don't do it well, suffer interpretability, and they don't use space efficiently. So it's not, they need more space. So whatever you use, there's these trade-offs as very often, and you should just be aware of them and then use the appropriate visualization design. Here's a couple of examples of where that simply didn't go well, right? These are examples of chart chunk that doesn't add a benefit. Here we have like a banana exports 3D bar chart for different countries over different years and volumes with a banana figure in the background. So, well, yes, I might remember that this is about bananas eventually, but it's I can't read the actual data. I can't accurately read the data from this chart. And similarly, these. We've talked about 3D and why it's a bad idea. Here is convictions in England and Wales for Class A drug supply across different ethnicities and races. And why? There is simply no point. This is one pie chart, and this person just added 6 or 7 more to make it look good and to have a 3D effect in here. So, yeah. Alignment also matters. So when you consciously create a visualization, like this here is a fine visualization. This is about lying, with what is the website? PolitiFact. So this is a fact-checking website, and that shows for all of these people, from Trump, Bachmann, Cruz, Gingrich, Palin, down to Obama, Clinton, Bush, and Bernie Sanders, and so on. It shows how many of the statements that they checked were pants on fire, fake, false, mostly false, half true, mostly true and true. And so this is an accurately designed chart, and it uses all of the design principles that we talked about, but you can actually improve it a little bit if you choose a baseline sensibly. So here we have essentially said, okay, our baseline is at least half true. And then we can very quickly spot, well, how much more does the Trump and Bachmann's lie that compared to the Clintons and Obamas according to PolitiFact, right? So we have not changed the data, we have not changed the representation much, we only have made a judgment call of how to align these data sets. And so these kinds of things, they do also matter, and you have to be thinking about them when you design a chart like that. We talked about 3D before. I just want to reiterate this point of no unjustified 3D. Remember from the lecture on perception, and also from when we talked about the Marxist channel, that we have the Stevens psychophysical power law, where we have the relationship between the physical intensity of a stimulus and the perceived sensation of the stimulus, where we had length as the only accurate one, and depth perception here is we tend to underestimate it. And so that's one of the reasons why you shouldn't use 3D. You also have problems with occlusion. So if you, for example, did try to render a bar chart in 3D, or a node link diagram in 3D, you might not see parts of the structure because some elements some other elements are in front of it, right? And if you just do this as a planar projection, you can actually have an algorithm that makes sure that you don't have overlaps between nodes. Whenever you use 3D, you need, since this is not, like we don't have stereoscopic 3D on our screens, we need to kind of like convey depth in some other way. And one of those ways is perspective distortion. So we use in computer graphics, we use like an artificial vanishing point and distort elements towards that vanishing point. We use lighting and shadows, and we've seen in the perception lectures how lighting and shadows and shading affects our perception of colors, so we cannot accurately compare colored elements in 3D whenever we use lighting or shadows, which we do need to get a depth perception. And then tilted text is illegible. So if you have text in a 3D chart and it's somewhere like in a projection, it won't be readable. There's ways around that. I can kind of billboard the text, but still it is a problem. Here is an example. This is actually those two people, Frank van Ham and Jaak van Wijk. They're very, very respected visualization researchers. Both of them from the Netherlands. And so this was from the wild years of information visualization. And here they were kind of like experimenting with how can we visualize hierarchies, like trees. And so they came up with this beam tree. And so their idea was, well, I simply like have a log here. And then the next level in the hierarchy are other logs that we simply put next to it. And so they chose to use this adjacency in 3D to visualize a tree. What do you think? Does it work? No. So there's like lots of problem with that, right? We have all of these problems of 3 dimensions and all of the lighting problems that I mentioned and so on. But still, this is also just to show you that these are two very respected visualization researchers, and only 15 years ago they published a technique like that. And the kind of also shows you a little bit about how young this field actually is. Like 15 years ago, math was basically the same as it is now. Visualization has changed a lot since then. Here is a chart, and the idea here is this is a temporal chart about fertility compared to the United States and Japan fertility rates. So here on the y-axis we have the birth per woman. Birth per woman, and on the x-axis we have the age. So we can see that there is like in the United States there were roughly at 20 it was, or 23 was kind of the peak in 1996 when women had their children, whereas in Japan it was roughly like at 28. So, but this chart is also, this is an animated chart that actually shows this over time. So we see this moves from 90, 80, or from 90, 50 something to recently. Okay, so what is the trend? What did you see?
In Japan, the fertility rate kind of dropped for the Middle Ages.
Yeah. Did you find it easy to spot the trends here? Yeah. Yes? Okay, so look at it again. So what you can see if you pay attention here is that the peaks get much smaller, right, and they get like stretched out a little bit. But we have to consciously focus and pay attention over a longer period of time. This chart is not badly designed by any standards that we've discussed so far, right? It uses a correct axis. It uses position as the position under the curve to encode the data. We have only 2 colors, so by any means this seems to be a chart that is well designed by the standards that we've talked about so far. But I would argue that this is not a great chart. It doesn't really represent, it doesn't get the point across that it wants to make. And so here are a couple of redesigns of that chart. one principle here that we have is this idea of eye-speed memory. And so when we can visually compare things that are next to each other, it's much better for us to make these comparisons than if we have a temporal sequence and animation that is playing in front of our eyes. And that is exactly what we had here. And so if you apply that rule here, eye-speed memory, simplistically you will get a chart like this, where you have simply all of these charts next to each other. And you can see, like here we have a massive peak, and then that keeps going slower, keeps going lower. So what's the problem with that chart? Anybody?
Well, that or this.
This one.
When it goes to a new line, you can't really compare like between the year before, so it's not really temporal.
That's true. And it's also very small, right? We have many years here. And so, well, you would actually think that fertility rate doesn't change rapidly from year to year. So maybe some kind of aggregation can be sensible here. So we could say simply aggregate like every 5 years here. There's 1947, 1950, 1955. So we have much fewer charts, and we still can see the same. Like we don't need all of the charts to understand what is in this data set. So we see this effect quite clearly here. So that would be a better chart, I would argue. But actually, you could even completely simplify it. You don't have to plot the raw data. The question that you should always ask is, what is the message that you want to convey? So I can simplify this chart significantly by not trying to plot the fertility rate and the age when people give birth in one chart, but instead separate them out and then have one plot for the total fertility rate in the United States. And you can see that the fertility rate in the United States peaked in 55 and then continued to drop slightly, whereas it was really high in the 50s and then it's now really low in 2010. And then the age at which women give birth, we can very clearly see that this is the same trend in the United States as it is in Japan, that we have kind of like this lowest age at when women give birth around 75, and then it increases again. So this chart contains actually all of the information that we had in these pretty complex animations, in these small multiples with 30 or 40 charts, and we can simply answer the questions that we might have here. Okay, so now I wanted to do a design critique. So this is the chart that we're looking at here. This is from a newspaper in New Zealand, and the question that the top chart here, I think, or the question that is asked here is, what do you think is the most important problem facing New Zealand today? And you have unemployment, jobs, economy in the top one, and then crime, violence, and race relations in the bottom one. And so I'll be handing out this chart, and then there's a couple of questions back here. Things like, what questions does this visualization answer? What data is represented? How is each data type encoded? Is the visual encoding appropriate? What could be the goals of the designer? Can you read the data precisely? And then like some personal statements. And then we will you will kind of critique this in a group again, as we've done before. Then in 5 minutes or so, we'll come together, discuss it as a group, and then you will have another 5 or 10 minutes to come up with a redesign. Okay, I'll be handing that out. Do you mind helping me?
That's the problem.
It's not.
It's a problem because you want to make sure it's smart. Right. There's a correlation between unemployment and economy, but there's not correlation between crime rates and what they're trying to what do you tell people? That's just the majority of the Yeah. there's missing data, right?
Okay, so what do you find? What is the data that is encoded here? What's the data?
Percentages of, I guess, worry.
Yes.
Worried about different problems.
Okay, and so these problems are unemployment, jobs, economy, crime, violence, and race relations, right? And so, what is the type of the data that we have here? Yeah, so we have percent here, number of people, percent of number of people, and if you break it down to the data type, spatial? It's, I would say this is like a quantitative data set, and if you want to be more specific, it's a ratio data set, right? Because we have a meaningful zero. So if nobody were to believe like that, we have a clear zero. Okay, what is the other aspect that we have, the other aspect of the data that we have in here? The relationships between the problems, but there's also something else.
Time.
Time, exactly. So we have these as trends over time. And so how is that encoded now?
Color, size, and the shape.
Color, size, what is the meaning of the shape?
Shape is kind of confusing. I mean, the circles are not, it's basically redundant. You don't need the circles. And it's, for example, in 2001, we've got 15% and 12% as a subset of that. It seems like is 12% part of 15% or not? Whereas in 2003, you've got both as 9%, so it's kind of...
Yeah, so you're bringing up this part-of relationship that is kind of implied here, which is, do you think this is a part-of relationship that they're trying to show here? No. So I would say the shape here is not actually a channel. They don't use it to encode it, but it's the mark. So they use the mark, a circle as the mark, and they vary the size according to the data. And so how do they vary the size according to the data? By diameter, right? And what is the problem with that?
It should be area.
It should be area. We perceive those as area. So if we look, for example, at like here, at this particular segment here at the bottom, like here's a redesign. If we fixed this encoding by diameter, we would see that these relationships are quite different, especially like down here, like we have this 1 to 15% that looks like almost nothing to a massive subset, but it's actually, this relationship is much less pronounced here. And then one of you already noticed one other problem here with the way they arranged the data. That was like the nesting. And what is a particular problem with the nesting? Where they kind of have to break the rule.
Yeah, 2003.
Yes. So 2003, they used this nesting for whatever reason. And then we have two values that are identical, and suddenly the nesting is broken, right? Because we couldn't tell whether the other value isn't there or not. So that is a problem. Okay, so now let me just see my slides. I don't have anything else to say. Okay. So, oh yeah, and then we talked about the color, right? And so why do you think that they separated this into these two segments here?
One is like economic problems, the other are social problems.
Yes, that's true. And so, like, what do you think about this chart? Can you read what it's supposed to say? Even like, let's assume that we don't have the obvious mistake with the area. So let's assume we have this chart. Do you think this would be a good chart? No. And what are the problems? Like, can we see trends, for example, easily? Yeah. Okay, so next in the next 5 minutes or so, try to come up with 2 redesigns for that. I again have paper here. I'll be going around the classroom and taking pictures of your redesigns. And if we have time, I'll be showing 1 or 2 of them.
the other one is unemployment. The other one is should I read the latest?
I mean, that's what I mean.
14, 13, 28, 10, 11, 13, 15, 11, 2007, 30. Yeah. 11, yeah. I think this will be something. I think it's 2004. Yeah, 2003 is 30.
How about a line chart?
2004 is 28.
Yeah, I mean,
2008 is 15.
Yeah, and this is the
11.
yeah.
9. Six, 9, 6, 9,
This also this is good. What about each year? Is that
Yes, we call them like 7 and then like represented the y-axis. So unemployment I think that's 5, 4, 3, 4, 14, 13, 14.
Yeah. We'll raise problems up here. Okay, so what were the designs that you came up with? Who wants to kind of like talk about their design? I don't think I have to take pictures for this one. It's fairly easy, right? Yeah. Do you want to draw it or just talk about it?
Anything? What would be?
Whatever you prefer. You can go to the whiteboard or you can just talk about it.
Yeah, I just go down.
Okay.
I just talked you through.
Take that one.
Yeah.
So, do you mind walking us through about your painting?
Yeah, sure. So this one is like a bar chart where this is going to represent the velocity, and then part of it will be inside this one, which would correspond. This would correspond to the unemployment section,
Okay.
and this would be economic.
Okay. So then you would have this over time. And so, can I make a suggestion? How about you, instead of drawing this as bars, you could just draw it as like lines, for example. Because then you don't have the overlap problem, right? If you have two exactly bars of the same size, you would have the overlap problem here, like if you have two 90% bars. You could, of course, like you show this a little bit of a distance here, but still, so that is a good design. Does anybody else have another idea? Or you can just talk me through it and I'll draw it.
Basically, so this would be the percentage. This would be
Years?
yeah. So each year you have basically 4 categories. So you either use color encoding for different color nodes, or you use different shapes. For example, this could be one. The second one could be something else. Either this way, different shapes, and they would form kind of.
So I get line chart. Yeah, so this seems a very sensible solution for this problem, right? So if we look at this, the redesign that this person here has done, we can see if we simply plot this as a line graph, we can see almost everything that we care about. It's much easier, much simpler, right? So you can either do this as a bar graph, but in this case, because we have temporal data, a line graph is just fine. We could consider maybe like a stacked bar graph if we wanted to, but this seems to be the most sensible solution. Okay, we have about 2 minutes left, which means that it doesn't really make sense to go into tasks, which means we'll be closing for today.